So next we are going to see that unit vector. Unit vector, you know that a vector is divided by its own magnitude is called unit vector. A vector divided by its own magnitude is called a unit vector. That unit vector indicates the direction of the vector. So see that this is the three axes x, y, z axis. That O is the origin. Three different colors are indicating the direction of the vector. Suppose you are taking the vector in these three coordinate axes. So x axis, that will indicate the direction, that is I vector. So I is the direction of the x axis, and j is the direction of y axis, and k is the direction of z axis. That will indicate the direction. So I, j, k are the unit vectors indicating the direction of the three vectors x, y, z axis, coordinate axis. They are perpendicular to each other. Three vectors I, j, k. So analytical method of vector algebra. So you can take the two axes, x axis, y axis. In that two axis, it is two-dimensional motion. Already you know that two-dimensional means you are using the two axes, x axis and y axis. The car is moving in a curved path. So when the car is moving in a curved path, you can see that the curved path means definitely you will use the two axes. So you can take that x axis and the y axis. This curved path. The car is moving in a curved path. So here we are going to take the vector OA. That take the two positions. We are drawing a straight line to the x axis and y axis. You can get A1 and A2. So the resultant vector A equal to, you are adding the two vectors A1 plus A2. A1 plus A2. You can take that inside for equation 1. So from O to A1, that distance, that is x axis, AX into I. Because it is the x direction, that is I cap. I cap is the unit vector. So the unit vector indicating the shape or hat. So A2 is y axis. So A2 equal to AYJ. So resultant vector, you have to add the two vectors 2 and 3. Substitute in equation 1. You will get A equal to AXI plus AYJ. So adding the two components, AX and AY are the two components. We are dividing that one vector into two component vector, A into AX, AY, like that. So AX and AY. So see, it's like a rectangular shape. So AY, OAY is equal to this side. So AX equal to A cos theta. You can write that theta is there. Cos theta equal to AX by A. That's why you are writing that. AY equal to A sin theta. So AX equal to A cos theta. It's the horizontal component. It's called the horizontal component. AY equal to A sin theta is called the vertical component. It's in Y axis. So AX and AY positive or negative or 0. It can take any value. So it is depending on the vector. So from that theta angle, we can add the two values. So the resultant vector A equal to the two components. This is called the resolution of vector. It is also called the resolution of vector. We are taking the two component, x component and y component. Ax equal to A cos theta is the x component. Ay equal to A sin theta is the y component. So horizontal component, it can also say that horizontal component and vertical component, Ax and Ay. So you can write like this. So Ax plus Ay. So Ax square plus Ay square equal to, you can write A square cos square theta plus A square sin square theta. Or you can take out A square outside, you can write cos square theta plus sin square theta equal to A square. Because cos square theta plus sin square theta becomes 1. A square equal to Ax square plus Ay square, or you can write A equal to root of Ax square plus Ay square. So this is the magnitude of that vector. So always we have to calculate the magnitude. Suppose you are asking that any magnitude of the vector, you have to do the calculation like this. A equal to root of Ax square plus Ay square, or tan theta. We can see that tan theta, theta is here. Tan theta equal to opposite side by hypotenuse. Opposite side is the AY. It is a y component. And adjacent side, it is x component. So that is why it is write ax. So tan theta equal to ay by ax, or theta equal to tan in the it's a tan inverse. So theta equal to tan inverse of ax by ay by ax. So it's a method of calculating the tan y. For an example, you can do that one calculation. A equal to a 7i plus 3j, b equal to 5i plus 8j. So you can add the two vectors. So now you can see that how to add the two vectors. So graphically you are going to represent in a two-dimensional picture. See that x-axis, y-axis. So 7i plus 3j. Upon x-axis 7, y-axis 3. So you have to mark in that pointer. So that is called the a vector, 7i plus 3j. So that is the point. In x-axis 7, y-axis 3. At the same time, b vector, that is 5i plus 8j. So in x-axis 5, y-axis 8. So in x-axis 5, y-axis 8. So you can mark that another one point. So you put that into b vector. So a vector is line is joined from O to that point. The same thing you can do for the b vector also. 5i plus 8j. You can draw the straight line. That point is called 5, 8. That is b. So now we have to add the two vectors. We have to add the x component and y component. See, so we have to add like this. So it is like a parallelogram law of vectors. So the resultant will give the total magnitude of the two vectors. That is 12, 11. It is a graphical method. So you can do that in method ordinary method also. Here they are adding that I component. That is x component 5 plus 7 and y component 8 plus 3. That is 11. So that will give the direction. So without graph, we can add that ordinary algebraic method. So this is a method of calculating the addition of two vectors. This is ordinary algebraic method. Okay, so these are addition of vectors in the two dimensions. So you can do that same calculation in three-dimensional space also. So x, y, z. That means here we are going to add the another one component I, j, k. Okay, three axes. It's this type of mostly is called three-dimensional space. So this is a three-dimensional space. You have to indicating the vector like this. So this is a alpha. That is vector with the x-axis. Angle between the vector and the x-axis. Then vector with the y-axis beta. Then vector with z-axis is called gamma. That is an angle. Okay, it has a three angle. So the pink color line is a vector. So now you can see that how to add the three-dimensional space vectors. X, Y, Z axis. So Ax equal to A cos alpha. That is cos theta you can write. That is here cos alpha. Ay equal to A cos beta. And Az equal to A cos gamma. So these are all the angles and the magnitude. So the resultant vector equal to, you have to add all the vectors Ax plus Ay plus Az. So you can get I, J, K or the direction of the vector. Ay, Ax, Az are the magnitude. I, J, K are the direction. So direction into magnitude is called vector. So Ax, Ay, Az are the magnitude of the vector. Right? So I, J, K are the unit vectors that will indicate the direction. So to calculating the magnitude of vector A, you have to take the square root of and square of all the magnitude of vector Ax square plus Ay square plus Az square. Two-dimensional means you can add the two values Ax square plus Ay square. In three-dimensional, we are adding that another one component Az square. So example for that, here are the two vectors A and B. How we are going to add the, see that 6i plus 4j plus 9k, 4i plus 3j plus 2k. So another example for adding the two vectors in three-dimensional space. So now we can mark the three axes. 6 in the x-axis, 4 on y-axis, 9 in z-axis. So we can get like this 4j, 6j and 9k. So this is a one vector. It's a greater magnitude 6, 4, 9. Another one 4i plus 3j and 2k. That value is small See that, and dividing that, adding that, you will get the value like this. You can add that calculation on like an ordinary algebra. So you can add that I component, j component, and k component. So finally, you will get the result. So this is a graphical method. It is an ordinary algebraic method. Okay, so analytical method of vector algebra doing the calculation for 2-dimensional and 3-dimensional.